Evening world. So tonight we are going to be exploring some asteroids. Really looking forward to that. Welcome everyone. I'm Irene Pease, your friendly neighborhood astronomer, and this is your Thursday evening tour around your celestial neighborhood. So glad you could join me. So glad Facebook and things are working, kind of, sort of. I had to download and update and some things today. So yeah, we're just gonna hope that it all actually works. Uh, the new version of OBS just fresh off the OBS whatever. So tonight, again, asteroids. I don't know if anyone's ever seen any asteroids. They're coming for us, so stick around long enough and you just might live to see one up close and personal. But in the meantime, we'll see where you might be able to find one in the night sky, and we'll do some viewing from a relatively safe distance. In the background right now, you see open space, so we'll be using open space a little bit more later. You can download it for free at openspaceproject.com, and I'm going to be just momentarily popping over to Stellarium, which you can download at stellarium.org. So Stellarium I like to use to kind of find my way around the night sky, do my observing, planning. Fits on my desktop, fits on my computer. It's a really great app for that. Learned all about it last night. I did an amazing AAA class with Kuiper Cat and Faisal. So yeah, so this is the desktop that I usually use in here. You can, put Mount Prospect from Brooklyn in there and everything, and our glorious evening skies. So not, let's see, not a whole lot. I believe there's a moon out. I actually saw the moon out my window of all things the other night, which is amazing because mostly I have a view of a brick wall. But the moon is out nice and high. Late, it's going to be getting pretty full, I believe, this week, and then kind of fading after that, waning after that. So I've been doing a lot of winter constellations, and I'm kind of skipping ahead a little bit because we want to find an asteroid, remember? Um, so, so we're actually going to head over to where the moon is tonight. So if you have clear skies tonight, I believe we have clear skies over in New York City area. If you go outside after the live stream, or stand outside right now, I guess. You can see that. So the moon is in this kind of nifty constellation. It's one of the few that I think actually looks like what it's supposed to be. And I'm just going to fast forward. Actually, no, we'll leave the moon right there. So that's where the moon is tonight. But if we kind of zoom in on that part of the sky, oh wow, we can already see where where our asteroid is. It looks kind of like this giant backwards question mark. So that's kind of the hook or the question mark of Leo the lion. So that's like the big head of the lion, big shaggy mane around there. That's the pandemic haircut on the lion, nice and shaggy. And then the bright star Regulus is basically at the heart of the lion, and his paws are kind of folded in front of him. Yeah, so like these two stars, kind of paws folded, and then he's lying down like a lion should be because he's a lion, right? And then his tail's kind of curved around. So a lot of times Leo is drawn standing up. I see him lying down, and here it looks like he's about to eat the moon, so watch out, moon. Flee for your life. But in the coming days, the moon will be, just passing through it tomorrow night, the next night, and then it'll be kind of moving away from Leo. So if you want to use the moon to help you pick that out, again, the big backward question mark is kind of the brighter part, the really notable part of Leo the lion. I'm actually going to move this to a little bit later in the evening, so it's a little bit higher to point towards, and maybe a few more days. So we can see Vesta. That's one of the largest, the second largest, the second most massive body in the asteroid belt is kind of zipping along here. So Vesta is relatively close right now. It's going to be at opposition on March 4th. Right? So that's where it's basically opposite us from the sun. And then usually things are at perigee, so the closest point to the Earth, a few days later. So I believe it's March 8th, Vesta reaches perigee. So around that time, so it's a couple weeks away, you can start planning now. um, that would be a good time to try to actually spot it with binoculars, with a telescope. It's going to be like sixth magnitude. So nice and bright, 6.1 on the 8th of March. So something to mark your calendars for. So if we kind of watch it, um, remember how to watch things in stellarium. You can see, if you're familiar, we're starting to see like the Leo trio in here if you're a galaxy hunter type. Um, so the back part of Leo, there's like this kind of V shape, I guess, with Denebula, its bright tail star. And then you have, I want to say Theta and some other star, Delta. Yeah, so Theta and Delta Leonis. Um, so if you imagine this V in here, Vesta, which also starts with a V, so that should be easy to remember. Vesta is just kind of tracking along in that V. So a few nights before, it's going to be a little bit closer to Denebula, but on the 8th, it's going to be pretty much along a line connecting those other two stars, Theta and Delta, and just about a quarter of the way from the more southern star, Theta. So definitely a fun opportunity coming up to try to catch an asteroid. If you've never seen an asteroid through binoculars or a telescope, again, even from Brooklyn, I'm expecting to be able to see that with binoculars. So if I can see it from Brooklyn, figure you can see it from anywhere. You will need some equipment, probably not naked eye, because sixth magnitude, I mean, you'd have to have like super perfect skies and super perfect eyes. But if you do, good for you, right? So your naked eye observing for the coming weeks is picking out Leo, the constellation Leo up there, and then if you have binoculars and or a telescope, see if you can catch Vesta in the next couple weeks. Let me know how that goes. So we're gonna pop back on over to open space then. Stretch our legs, get out there into space, the open space. Ah, it's always so refreshing. And again, we're looking for asteroids. So I just realized I need to turn off a data set real quick here. We don't get too many asteroids real close to Earth, we hope. Inevitably, we get some, right? So it only takes one, but but they're out there. So as promised for the current missions class, another fabulous AAA class you can take if you join the Amateur Astronomers Association. Just saying. If we zoom out here, we talked a little bit about some asteroids this week, and we're going to kind of zoom in and see a little bit more of some asteroids, the larger asteroids, in detail here. So most of the asteroids people are familiar with are in the main belt. So that's going to be between the orbits of Mars and Jupiter. So you have the inner planets, Mercury, Venus, Earth, Mars, and then you have, it's not just wasted space. Like there's stuff in there, a lot of stuff, and it's mostly small. We have 1 or 2 million basically that are a kilometer or more across, which is, it's not too bad, not too shabby. So we've kind of broken up into data sets into separate chunks here, because if I try to load them all, my computer cries and weeps at me. So there's the inner main belt, right? So that's basically just outside the orbit of Mars. There's a whole bunch of stuff there. Great, good for it. Can stay out there. And there's the outer main belt, so there you're getting out closer to Jupiter. Great. And there's a whole bunch more in between, but that data set breaks my computer, so I'm not going to show that one. Oh, and I just noticed a nebula. Oh yeah, Dr. Fox. Maybe. So lots of stuff out there, and that's where we're gonna head. Actually, in our missions class, we talked about some recent missions to some things that are in closer. So we'll kind of save those for the end. So we have 2 current missions, Hayabusa 2, that stopped by Ryugu, and it's on its way to another small body. Has the glorious, marvelous name 1998 KY26. Someone needs to change that. And then also OSIRIS-REx is now on its way back from Bennu. So those are a little bit closer in, but let's go ahead and just take a look at some of that stuff that is more out in the main belt. Because I just got some fabulous maps loaded in here today with the help of Micah from Open Space. So shout out. Thanks, Micah, for helping me with that. So the first one I want to visit actually is technically not an asteroid. So we're going to zoom in right in this area in here. I'm not even going to bother turning on a trail for it. Pretty sure it's here. I may need to turn on. Yeah, there it is. The big gray ping pong ball in the sky. That's the one. So this is actually the largest and most massive object in the asteroid belt. And we actually do have pretty maps of it. I think I like this one better. So ages ago, like over the last decade, another mission, Dawn, visited both Vesta and this one, Ceres. So first Dawn went to Vesta from about 2011 to 2012, and then it popped over to Ceres 2015 to 2018. And as far as we know, I think it's still orbiting Ceres, just hanging out. So it lost, it ran out of fuel, so it couldn't aim itself to send messages back to Earth. So it just kind of put itself into a nice little orbit around this cozy little dwarf planet of all things. So Ceres wasn't always a dwarf planet. That's a relatively recent phenomenon. The last, well, just this century, really. The label of dwarf planet has fallen upon several worlds in our solar system. When Ceres was first discovered way back over 200 years ago, 1801, the dawn of another century, it was a planet because it was a big thing. Like this was before even Neptune was discovered. So they found this other cool thing between the orbits of Mars and Jupiter. It's like, wow, we have 8 planets now. Mercury, Venus, Earth, Mars, Ceres, Jupiter, Saturn, Uranus. So exciting. But then they started finding more. So within just a decade, they found Pallas and Juno and Vesta. And within a few decades, they'd found over 100. And they said, okay, yeah, these are not all going to be planets. Not going to happen. So they decided to call these asteroids. So Ceres was a planet and then was reclassified as an asteroid with some other asteroids. And then more recently, reclassified again as a dwarf planet. Because if I turn on this shading, woo, right? So pretend that the sun is shining on all of it so we can see the whole thing at the same time. We can see it's relatively round, right? So it looks like a moon. It looks big and like planet shaped and stuff. And it is. So it's big enough to have pulled itself into a sphere. It's not a peanut. It's not some weird triangle-y Mars moon kind of thing. It's in what we call hydrostatic equilibrium, right? So it's massive enough to have pulled itself into a sphere. Go Ceres for the win. All right. But since it's in a big debris field, it gets classified as a dwarf planet, blah, blah, blah. Get mad at the IAU, not me. So it has some interesting features, which you might notice. It's very dark. It's a C-type asteroid, which means it's very dark. It's got a lot of carbon and it's not super reflective. It has a relatively low reflectivity, or what we call albedo in astronomy land. And except for a couple spots. Right, so I'm kind of panning around. I'm pretty sure it's actually this crater that has like the bright spots in it that was named after the person who discovered it, Giuseppe Piazzi. So as dawn was coming in on it, they were like, "Oh, it has dots. That's interesting. Could it be ice? Could it be, what could that be? Something highly reflective, like, water ice, because there's a lot of water all over the solar system and it's always exciting to find more." So they took a close look, and turns out that it's probably not actually water ice. but it's a bunch of saltiness where there used to be water ice. So basically, evidence of, and they found more evidence since, of cryovolcanism. So on Earth, we have volcanism, we have volcanoes that spew out our hot, saucy mantle material, this lava from the inner parts of the Earth. And on other worlds where it's much colder and they have a lot of water beneath their surface, those will spew out ice and like water ice and vapors and whatnot. So so Enceladus, Europa, you might be familiar with those having cryovolcanoes. We actually have seen them like spewing material out into space. Triton, one of the moons of Neptune, um, may also have some. So there's other worlds, other, well, moons. But this was the first dwarf planet that we saw that had cryovolcanism, which is pretty cool. So we think there's a whole bunch of water, like a really mushy mantle, very wet mantle beneath the surface of Ceres, and when that gets spewed out, it brings all these salts with it. But the water like freezes. It's freezing, and when the sun shines on it, it sublimates, so it turns into a gas, and it's not there anymore. But it leaves the salts behind. So think like salt flats, right? So if you have a bunch of salts dissolved in water, the water evaporates, the salt's left behind. So that's what we're seeing, we think. And these bright white spots, those are salty bits, briny bits from this briny stuff that was spewed up from inside of it. So a couple other regions where they have like these bright white spots that are pretty cool. So yeah, lots of water probably beneath the surface in the mantle, but it's not like, it doesn't have like the rocky core that the rocky planets have, like Mercury, Venus, Earth, Mars. Probably doesn't have that. One of the other fun features, I was trying to find it earlier, was this one particular snowman. So you'll notice a lot of craters. It gets struck a lot, so no atmosphere. The thing is only like, it's just shy of 1,000 kilometers across, like 940 kilometers in diameter. So not huge. But still the biggest thing and the most massive thing in the asteroid belt. And so it attracts plenty of stuff, and plenty of things smash into it and leave all these fun craters. And so some of the craters are stacked. There's this one place where it's like 3 really distinct craters that form a really cute snowman. And if you go online, there's people who've actually annotated it and given it like a little carrot nose and a hat and a scarf and everything. So you can look up that stuff in all your spare time. And I forgot the other thing that I wanted to say about it, so it must not have been too terribly important. But that's Ceres, right? So Ceres, pretty cool. But it's safely far, far away in the asteroid belt, like the main belt, like it's not going to hit us. So yay. So that was yeah, that was the second stop of the Dawn mission, which made the Dawn mission the first solar system mission to orbit 2 different bodies. So they were small bits, but they were bits. And one of them was an asteroid and one of them was a dwarf planet, which is pretty nifty. So Ceres, and then the first target is the other asteroid that I want to stop by. Oh, I think I just totally left the solar system. I want to stop by its first target, Vesta. Oh, Vesta. There's so much going on with the Vesta. And that's in our asteroid belt. I can actually turn on its trail. So that one you can see is a little bit closer in, a little bit closer to the orbit of Mars. So hence Vesta and then Ceres, as Dawn was flying out. Some other cool things about Dawn. It had an ion propulsion system, so it was a slow acceleration, but it added up over time. So by the time it was retired, it actually had the greatest total change in velocity of any craft on its own. And that change in velocity was basically equivalent to the escape speed for Earth, which is kind of impressive. So Vesta. So Vesta is going to be a little bit different. as we'll see here. Let's go ahead and look at it kind of along its equator-ish. Yeah, that's a cute little rock in space. Okay, so Vesta is, again, it's the second most massive body in the asteroid belt, but it's not the second largest size-wise. So Pallas is actually slightly bigger, but Vesta is much more massive, like not just a little bit more massive, it's a lot more massive, which basically tells you it's a lot more dense than Pallas. It's probably more dense than Ceres. Vesta is very special. We've actually had pieces of Vesta without having a sample return mission because Vesta, crazy storied history. It's the only remaining protoplanetary body that we know of in the solar system that didn't actually become a planet. So what in the world does that mean? Well, Ceres got kudos for being able to pull itself into a sphere. Great, go Ceres. So that means it has a lot of mass. And usually when things, okay, no shading on that one. When when things have a lot of mass, it'll get really hot near the center, and you get some melting, which means that heavier things can move through the fluid if you have like a fluid as opposed to a bunch of solids. You can kind of do it with solids too, but like a fruit smoothie or a veggie smoothie, right? The dense stuff, the gunk, sinks to the bottom, and then you have juice, and they have frothy goo on top. So like that's how the planets, the terrestrial planets, are layered, right? So like the crust where we live, that's basically the pond scum of the earth. Like it's just the goo on top, and the dense stuff in the middle. So the other asteroids, even Ceres, hasn't really done that, but Vesta did. So Vesta is a differentiated body. It's like this prime, like primordial planet type thing. So it's not like primordial material like we get from some other objects in the solar system, like the more current missions. But it's fascinating that it's this little nut. Yeah, it looks kind of like a walnut. So think of it as a little nut that's encapsulating a very, very young planet from early in the solar system. So that's kind of nifty. So yeah, so why does it have this walnut feature? Oh, Vesta. So it has these ridges, much grander than the Grand Canyon. So not quite like Valles Marineris, but if you want to compare to Grand Canyon, I don't actually have the comparison. I just call them skid marks. But the largest one, so it has several. The largest one, I think it's like kind of along here. I don't know, whichever one looks longest and largest. Devalia Fossa. It's about 10 to 20 kilometers wide at different points and 465 kilometers long. So Vesta's diameter is only 525 kilometers. All right. So the 465 kilometers, that's like a good portion of the way around Vesta. So pretty big, pretty deep, kind of grand, but probably wouldn't want to visit per se. It also has some amazing mountains, and the reason it might be shaped so squashedly is from not one but two super huge impact events. And I think the one I actually want to go to is on the, wow, oh man, just look at that, it's huge craters. All right, so North Pole, so I think we want to look towards the south. There's, yeah, so if Santa landed and went just like skidding around the thing. All right, so I'm just gonna pause here. So if we just kind of rotate a little bit, you'll notice it's kind of flat, but then there's like this bulge, like a pimple on the bottom of it. All right. So, so what in the world is that? That's a huge mountain that's inside of a huge crater. There's actually, I think, two huge craters down here. So this would be from one of the huge impact events that affected it, we think. So inside of this crater, it's Rhea Silvia crater, and the mountain, like the central peak, you get central peaks inside of a lot of these huge craters that do like serious damage to a world. It's like 21, 22 kilometers high. So it's debatable, like at first they thought it was like taller even than Olympus Mons. So we generally think of Olympus Mons as being the tallest mountain in the solar system base to peak. Um, but Olympus Mons is right around 21 kilometers base to peak, and this one apparently is too. So I'm not going to argue, but I'm just going to say for a dinky little asteroid, although it's technically the biggest asteroid because Ceres isn't actually an asteroid, it's a dwarf planet. But so for the biggest asteroid in the main belt, that's pretty impressive. Like even though it's just an asteroid, has these huge gashes that can compete with the Grand Canyon, and this huge mountain that can compete with Olympus Mons, guys. Like that's just who does that? Anyway, um, yeah. So from these two huge collisions, again, not one but two huge collisions, one of which basically left this behind. um, and apparently these collisions happened late enough that it couldn't really reform to make a nice round shape. Like it should be massive enough to pull itself into a nice round shape, but it got, kind of a little bit damaged there. So from those, bits of Vesta have been spewed all over that part of the solar system, all through the main belt. So we have, there's actually a type of asteroids, the V types, they're V for Vesta, because they're all bodies that originated from Vesta. So a whole class of asteroids that it kind of gave birth to in I guess, a really painful way. I'm gonna see if I could just turn time on a little bit so it'll spin around for us instead of me trying to. Oh yeah, I have to do this. Whoa, that's too fast. Okay. Um, bits of it flying off everywhere, right? So, so there's bits of it all over the solar system, including on Earth. So there's whole classes of meteorites, right? So we don't have samples directly from Vesta, but we have samples that have traveled around the solar system a few times and landed on Earth in the form of meteorites. So the HEP meteorites, or HED meteorites, the Howardites, Euchreites, and Diogenites, all originate from Vesta. So they're different parts of those impact events from like a billion years ago. So pretty cool. I actually know people who have Euchreites, like they have pieces of Vesta, and I know we have it at the American Museum of Natural History in the Hall of Meteorites. So when you get a chance, get tickets, go check it out, see pieces of Vesta, and be like a fun thing. So there's Vesta out there, had a little friend for a brief amount of time. But those are out at a safe distance again in the main belt. Okay. So just a friendly reminder that there's a lot of stuff that's a lot closer than the main belt, right? So that's what I just want to kind of leave us with a little bit here. If I pause time and if I can center on the sun, just to, yeah. So again, most of the asteroids and those two largest ones that we just saw, those are out past the orbit of Mars. Nice, safe distance. But there's these other classes of asteroids that are not so safe. Actually, by definition, they're, not. So we have several groups of Earth-crossing asteroids. One of them are the Apollos. So there's a lot of those. And it's kind of funny if you look at this, like there's like a whole chunk right in here, like really close to Earth. Probably observation bias. Like it's easier to see them because they're mostly really small. So like the recent missions, or the current missions, I should say, to asteroids. So Bennu and Ryugu, those were both Apollo asteroids, and the one 1998 KY-26 that Hayabusa 2 is on its way to, should get there in about 10 years. That's also an Apollo asteroid. To just kind of give you a clearer picture, I just wanted to bring up the the Bennu. Oh, do I have it in here? I may have turned off my Bennu trail. There we go. So you can kind of get a sense of like these kind of Earth crossing, these near Earth asteroids that basically have orbits. For the Apollo ones, they're just kind of outside, mostly just outside the Earth's orbit, right? But it actually goes across there. So that's really handy for missions because it's a little bit easier to get to them for pretty cheap. Um, and again, that tiny one that's being approached, that will be the smallest thing to be orbited, to be visited, is only 20 to 40 meters across. So really, really puny things. And these are also part of not just the Earth crossing and near Earth bodies, but these are part of a group that we like to call potentially hazardous, which is just as terrifying as it sounds. Um, so yeah, things that could potentially be hazard to the Earth. So we're also studying a lot of those. One, we want to know where they are, because again, it's not if but when. But two, also because, we've gotten debris from Vesta out in the main belt. We could be getting debris from these as well. And these are rich in a lot of elements that we see in life. So, there's some people think, maybe life on Earth was seeded by comets and asteroids from, further out in the solar system. So studying some of these asteroids could also give us a little bit more of a hint of maybe where things on Earth came from. So that's kind of the end of the story. So asteroids are fun, they can be scary, but maybe life came from there. So giveth and taketh away. Anywho, on that happy note, I just want to say thanks for joining me. Shout out to the visuals that we used again. Again, you can find Stellarium at stellarium.org, and Open Space you can find at openspaceproject.com. I'm Irene Pease, your friendly neighborhood astronomer, touring around the solar system like you do. Thanks so much for joining me. Have a good week. Clear skies. Be safe out there. Don't forget to wear a mask.